Do you want to go to lunch to talk about your secret findings? So, have you found any new evidence yet?
Some interesting things, yeah. It's been kind of cool. Whoa!
You're under arrest for working with Germany. Get out!
Wait, stop! Did you guys know? This is my electrochemistry setup. It's how I measure the chemistry of the fluids I've been working with to study sulfur metabolizing microorganisms, like the kind that we think we found in other worlds potentially. This is what's called a gradient tube. It has sulfide in a plug of agar on one end, and the cap is slightly open to allow oxygen inside. And so a gradient forms along here of sulfide and oxygen. And these microorganisms metabolize sulfur. They find special little places inside of these tubes where they thrive, and it allows us to study them in their unique environments here in the lab and in the Arctic. And this is our anaerobic chamber. It's a glove hood where we make sure that the atmosphere inside has no oxygen in it. There's a meter up here that says 0 parts per million oxygen and only 2.3% hydrogen. So there's a hydrogen and nitrogen environment inside of this chamber, and it's where people who are doing work on microorganisms that survive in environments where there is no oxygen, it's how we do work on those organisms and how we study them in their unique environments. So as you can see, working inside of this glove bag, this hood, requires that I wear these gloves to manipulate things. It takes a long time to learn how to use these gloves well to manipulate objects because the fingers don't have very much dexterity. So just like an astronaut wearing gloves in space, when you're working inside of the glove bag, you have to be really diligent in how you manipulate the objects you're working with. Wait, stop! This is an ultra-low temperature freezer. It's where we preserve samples that are of interest in biological and chemical origin. If I put a cell inside of this freezer at -70°C, it will flash freeze that cell in such a way that it will preserve it over time, that it can't metabolize or do anything of importance, so I can save my samples for a long period of time. And when I pop it open and have a look inside, it's very cold and hard to work with, but I can touch it with my hands a little bit. If I held my hand here for too long though, my fingers would start to freeze. But inside of all these different sample containers is where I keep my materials from the Arctic. And this is my cold room. It's where we store samples at temperatures that aren't freezing, so it won't preserve the samples, it won't flash freeze them like that freezer would, but it will keep them in a cold state so that reactions don't happen very fast. For instance, some of the organisms that I'm studying from the Arctic, they prefer really cold environments. And so to reenact what they're going through on the surface of the glacier in these cold environments in the Arctic and possibly in other cold places in the universe, I have samples in here that I keep chilly. This sample, for instance, has a film of sulfur growing inside of it that has been biomineralized by microorganisms. And they do it over the period of months inside of this gradient tube where sulfide and oxygen are meeting. And if you look really closely, you can actually see the filaments of material growing. My favorite part about my job is being allowed to ask questions and go out really far onto a limb to try to figure out the answers to those questions. Being a scientist is about trying to figure out how our universe functions, from things as small as simple processes occurring here on our planet, from life and from geology, to greater things like how stars form and die and whether or not we're alone in the universe. My field site in Ellesmere Island in the high Arctic, as sulfur is forming on top of ice at a glacial site, we've recently discovered that the way that this thing is forming happens throughout the year, which we never knew before. We thought it only happened when the ice melted in the summertime and the water could come out of the glacier. And now we've realized that this sulfurous ice is forming in the winter when there's snow on top of it as well, which is a pretty cool thing for us to know about my field site. My research is trying to understand microbial ecology, so how these microorganisms work together to metabolize things in our environment. They take chemicals of one form and change them to another, and it's those products of that process that I'm looking at on our planet. It can help us to understand how something like sulfur is cycled through the subsurface on our planet to the surface, and how we can look at other planets in our solar system or even planets around other stars far away and look for some of those products and try to figure out if life is there, and if so, what life is doing.
Why were you working for Germany?
I didn't realize that what I was doing would be a crime. I thought that as a scientist who usually work internationally, that it would be okay to work with the European Space Agency and to help them on their projects studying Europa and these other icy worlds in our solar system.
Well, we'll let you continue doing your research as long as it's under us and you're not working undercover with Germany.
I would gladly work for you, or anyone, honestly. I'd gladly come and help you out. Scientists, we don't pick sides. We don't try to pick sides.